It was very handy to think of a 4D cube as a infinite stack of 3D cubes, that if we tried to visualize it, they would all overlap, but in 4D they're not supposed to overlap. Anyway, we like to think about things as being stacks of lower dimensional things. This works for triangles too. So here's a 2D triangle. Now you can think of this 2D triangle as a stack of shrinking 1D triangles, and this is what's going to make triangles different from cubes. Remember that a 1D triangle is just a line segment, and so on the very bottom you have the largest 1D triangle, the largest line segment, and then as you move upward you're going to have shrinking line segments, right? And so the farther up you move, the smaller the line segments get, all the way up until the very tippy top of this triangle where you have just a point. So a 2D triangle is a stack of 1D triangles which are shrinking down to a point. Move it up a dimension. Here's a tetrahedron, a 3D triangle. Now, instead of thinking of 2D triangles as a stack of shrinking 1D triangles, we are going to level this up a dimension. I can think of the 3D triangle as a stack of shrinking 2D triangles. The very base of this tetrahedron, what usually we think of as resting on the table, is the very biggest triangle that we have in our stack. And the farther up you move, the smaller those horizontal triangles get, until you get to the very tippy top, and the triangles get infinitely little tiny triangles, and the very topmost slice is just a point. Okay, well, by analogy then, that means you can think of a 4D triangle as a stack of 3D triangles which are shrinking. And so what I'm going to do is I'm going to draw that bottommost, biggest-most tetrahedron. Okay, and again, I'm not coloring in the faces, but that's a 3D triangle right there. And that's supposed to be the biggest one. The very topmost tetrahedron is supposed to be just a point, like the tetrahedra just shrank away to nothing. And so what I'm going to do is I'm going to draw these dotted lines connecting that point to the 4 vertices of the tetrahedron, just so I can show you that as you move up the stack, the tetrahedra are getting smaller and smaller and smaller. So you need to imagine as we go from the point down to the big base tetrahedron, there are infinitely many 3D solids all along here, and they're growing and growing and growing and growing, and then this is the guy that we consider to be on the bottom. So that is one way of thinking about a 4D triangle using 3D pictures.